All right. Hello, everybody, and welcome to the stream. I know we're getting a little bit of a late start tonight. Had some technical difficulties off camera that I got distracted with. And I also did not get the 7TV stuff done. So I will do that maybe towards the end of the stream. Soul Foam, I've not forgotten. How's it going, guys? Good to see you. Good to see you as well, Spiro. Thanks for joining. Redux Quack. I love it. Love the pun there. All right. So we're going to pick up where we left off last night, talking about scenes and trying to keep things data oriented in our sort of refactor that we're doing here. So I did just spend a little bit of time working on that, and then I kind of ran into some issues, and that's why we're starting late. So that is what is on the roster for tonight. I think that is going to make it a little bit of a shorter stream, but we'll see how far we get anyways. Before I start with that, though, I do want to take just a quick second and thank the supporters of the channel, beginning with our elite partners, who is Javier Alazaran. That is the highest tier of subscription over there on YouTube memberships and Patreon. I'd also like to thank our partners, Gerbolis Inc. and Matt Oscard. That's the next tier of subscription there. And I'd also like to thank all the other supporters listed under the supporters section here. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. And it's going to help me cover costs associated with running this project, software licensing, hosting fees, things like that. So thank you guys very much for that. And of course, I wouldn't be able to do any of this without you guys, the viewers. So I appreciate each and every one of you guys, whether you're joining us here on the YouTube side, the Twitch side, or you're catching the VOD after the fact. Thank you very much for being here. I appreciate you. All right. So, scene stuff. I actually did get a little bit of stuff sort of figured out. And I kind of did a little bit of brainstorming around some rules and some things that I'm going to wind up changing. So before we had this sort of system where if you wanted to define a transform for a particular node, you could do that. If you did not want to do that, you didn't have to. Which was all well and good, but it led to a lot of branching in the code, constantly checking to see if we had a transform or not. And then having to recurse up the tree to see if there's any transforms beyond that, right? Because you could technically have a node with a transform, and then another node with no transform underneath of it, and then another node underneath that with a transform. And you would have to skip nodes up the tree in order to actually accomplish that. We did have that working, but it wound up adding what I think is quite a lot of overhead just to kind of have that. And so we're actually going to switch back to every node is going to have a transform whether or not you use it. And that keeps us from having to have branching logic, right? Because it's much quicker to just burn through a whole bunch of matrix multiplications than it is to constantly branch your code for things like that, right? So that is one of the biggest things. Let me move this over here a little bit. There's that. That's this one here. I kind of went back and forth on it for a while, and that's kind of the direction I came up with. That being said, the two cases that I always used for not having to have a transform were always the skybox and directional light. But then I got thinking about it, and I'm like, you know what? Both of those can be rotated, technically. We could base the directional light and get a direction based off the quaternion rotation of its transform, right? And we can just ignore the position in the scale, right? But we could use the position also for placing a gizmo or allowing us to place an icon when we actually have those in the scene so that you can actually find it. And select it, and be able to inspect it and all that good stuff. So I think that between that and the skybox, it does actually make a little bit more sense to have transforms for those, because we might have a skybox and maybe we don't want the default orientation. Maybe we want to rotate at a certain number of degrees or something. And so that is what we have transitioned to in terms of nodes. Every node has a transform. The other thing, and we briefly discussed this last night, and I'm putting down I'm putting this down as a permanent decision, right? We are only going to define known node types. So user types are not going to be supported at this time. If we want to support that later on, we can add it if and when we need it. But it just adds a little bit too much overhead and a little bit too much logic and complexity for something we might not even wind up using. So we are only going to define known node types at this time. Let's see. So there's another thing we briefly talked about. If a node transform is modified, it's marked dirty and added to the dirty list. And then on update, we iterate the dirty list and any children of the dirty transforms to go through and update that, right? So we'll have some work to do around that. And then if a node is added after the scene is loaded, it should automatically begin its loading process. And this is kind of a precursor to what we're going to talk about in terms of the life cycle of a scene. We're going to simplify that too. So let's see. The node life cycle should be simplified to create and load immediately if the scene is loaded. Load, which is called by whenever the scene is actually loading, right? And then destroy. And even this load, the separate load, might not wind up happening, right? We might just combine create and load. Like as soon as we actually create the node, we just go ahead and load it right then and there. And if we jobify that, we're not going to see any sort of difference in terms of us actually being able to launch the scene. And then nodes should all calculate a bounding sphere influenced by its transform, with maybe a axis aligned bounding box later on. And so that's going to be something that we're going to have to add as well. We don't have anything in the scene for that. That's kind of the last thing that we're going to need to add. But that is basically what we're looking at making in terms of how our scene's going to work, at least from a high level. And then there's a couple of other things that we're going to discuss here in a second too. Let me go ahead and just catch up on chat. LaFolie, good to see you. How's it going? Pragma thrice. Yeah, I know, right? Pragma once. I like this a lot better than typing include guards all over the place, although it's technically not as portable. So at some point, I may have to go over the entire code base and fix that, but I don't think so. Most relatively modern compilers support it, so I'm not too worried about it. All right. So, when we talk about the scene state, now we have 4 states, essentially. We have uninitialized, which means that nothing is done. It's basically been, it's been either created and not actually started loading yet, or it's been destroyed, right? So it means basically nothing has been done. It's definitely not ready to use. Then we have the loading state, which is transitioned to once we actually start loading all of the nodes and whatnot in the scene, which kicks off all the resource loading and all that stuff. So when we're in process of loading the initial load of the scene, that's where we get the loading state. Once everything is loaded, the initial load anyways, we transition to the loaded state. So the loaded state is the only state that exists where the scene will actually be rendered. If the scene is not in loaded state, it should not be rendered. And then unloading is just another process that we can, or another state rather, that we can have. Once we trigger an unload, we set its state to unloading, so it immediately stops rendering. But then if we have any sort of things that require still frame updates to go through before we can actually unload those things, then we can go ahead and do those at that time. And then once everything is confirmed to be unloaded, it switches back to uninitialized. And so that is the simplified life cycle of the scene. Singy, how's it going over there on the YouTube side? Hello. Welcome. Okay. So the other thing that that's changed since the last stream is node type are actually bit flags now. And the reason I chose to do this is because of something that I call queries, which we're going to get into in a little bit. So a node can only have one type at a time, but there are situations where we need to talk about multiple types at a time. And so we are going to use these bit flags to indicate multiple types at once, or in the common case, just to get a single node's type or define a single node's type, we'd use these one at a time. So that's what all of those are, and then of course we have a define, or a type def right here, rather, for those combined bit flags. Same for mask bits, right? So we have a couple of things here in terms of masks for selection, typically. So we can select by things that cast a shadow, things that receive a shadow, and things that should be included in planar reflection. And we'll obviously be adding to this list, but for right now, there's the three I could think of. So those are included as well. And then we also have something else that's different from last night is before we had the KC node that was just a type def for a khandle16, and that has changed as well. And so a k-scene node is actually going to be used as a result of a scene query. And this contains all the information that we need to know to go ahead and load or retrieve data for the base node type. So that's all the shared data between all different types of nodes. And then the node type specific data as well. So we have two handles for that, which is kind of similar to how it works in other systems. And then we have the node type here for convenience as well. So whenever we do a query, we are going to be returning a series of these KC nodes and using those. Also, all of our API is going to be using these KC nodes as well. So you'll have to select what node or nodes you want to operate on from the scene in order to be able to operate on them, right? So that's what that is for. Let's see, k-scene transform data. So now that every node has a transform, we've eliminated the concept of a transform ID. The index into the positions, rotations, scales, world matrices, those are all in line with the k-scene node data, which is the base node type, right? And so when you're querying against this set of arrays, it's the same index that you would use to query against this. So that's another thing we were able to simplify. I don't believe we added too much of anything here other than the node masks, right, for querying purposes. So each node can have a set of masks associated with it, and we can set those there. So that's that. Let's see. And then I went through and defined a whole bunch of the specific node type data. So we knocked a bunch of these out last night, and I went ahead and I think finalized them. We might have to add another field or two here and there for some of these things. But these are the actual data for specific types of nodes. So that's what all these structures are. So we've got, let's see, actually this node type data, I don't think we actually need this. I think we can actually get rid of that one. And this one. Okay, so we don't need that. We have one for groups, right? These all have a base ID, so all of these types have a base ID. That is referenced here so that we can do a reverse lookup. So if we're iterating these guys, we also have a way to look up what the base node is, which we would need to also get the transform information, that kind of thing. So that's what that is. And then an allocated count. You'll see a couple of these types just have that. They don't actually contain data of their own. I didn't have to go through the process of setting these up. However, since the node type exists, I figured we're probably better off just going ahead and setting it up. That way, if we have to add fields to it later on, we don't have to scaffold all of these structures and set up all the memory management for all of them. We can just do that We could just do that for the single field, right? And so that's kind of the theme that you're going to see here with a couple of the node types that don't really have too much data on their own just yet. Let me see. I heard a ding. Thank you for the follow there. I appreciate that. Diamond, good to see you. Good evening to you as well. It is going well. Thank you for asking. Elpsy Streams, thank you for the stretch redeem. I could use that. Ooh, my spine just cracked. That's neat. Yeah, I've noticed as you get older, the more stuff cracks and pops the more you move around. It's like Rice Krispies up in this bee. All right. So yeah, thank you very much for the stretch redeem. I appreciate that. Corvo World Building over there on the YouTube side. How's it going? my knees crack every time I bend them. Yeah. Every time I get up from my chair, my ankles pop, my knees crack. If I sit down just right or I twist my back just right, my spine pops, my neck pops. It all pops. Rice Krispies up in here. Snap, crackle, pop. All right. So skyboxes are pretty straightforward, right? They have a cube map name and a pointer to a cube map texture. I'm not 100% sure that I'm going to have to keep the cube map name. I don't think I'm going to. But I'm basically just kind of keeping everything that I had in the old scene here for now, and we will kind of clean that up as necessary. So skybox data and directional light data are a little bit different than the others in that we can only have one of these things, right? So we don't have an array of things. We just have a single base ID, a single instance of all these other things, because we don't need to support multiple of them, right? We're only going to deal with one skybox at a time. We're only going to deal with one directional light at a time. And so those node type data reflect that. Okay. So the next thing we have is point light data. So again, we have our arrays of our colors, constant, F, linear, quadratic. I'd like to change this to some properties that are a little bit easier to use and a little easier to understand at some point, because this is kind of the math that happens under the hood, but we don't necessarily need to expose that. So at some point that will be changing. I should point out that I created a couple of new types as well. These are just type defs, right? I did start a kcolor file because we eventually are going to need utilities for dealing with color. And the first step of that is we are just defining color 3 and color 4 as a type def of vec3 and vec4. And then color 3i and color 4, whoops, that's a 1 instead of an I. Color 3i and color 4i are just the integer variants of that, right? So these would typically have a range for RGB 0 to 1 or RGBA 0 to 1. This would be RGB 0 to 255 and 0 to 255, right? So that is those. And any place that we're using color when we're talking about, even if it's going back and forth between shaders or whatever, I'm going to start switching that out just so that it's a little bit more clear from the type def there what the intended use of that is. All right, so that is our point light data. Our spawn point data, again, pretty straightforward stuff. All we really have here is radii for each of those spawn points, so nothing really too much to talk about there. Hit spheres, again, we just have radii for those. A static mesh just has a bunch of static mesh instances that we get from the static mesh system. This is an example of something that I may or may not wind up changing in the future, but we're not going to do it as part of this refactor. But basically, a static mesh instance allows us to use the same underlying static mesh resource, but maybe assign a different material to it or something like that. So there's that. And then I should also mention, as far as lights go, we do have a light system that is basically right now kind of managing these things. And I think I'm going to get rid of that too, because it didn't kind of work out the way that I wanted it to, and it doesn't really do all that much. So I think I'm going to wind up getting rid of that and just being able to query it from the scene. All right, so those are all the specific data types, right? I actually know there's a couple more. So there's one here for volume data, right? So we can configure different volumes. So those are here. And then we have water planes, and then we have audio emitters, and that is it, right? And then we also have tag data, which we'll tackle maybe not right away, but sometime soon. I just wanted to get it sort of set up. And then as far as the scene goes, all of our specific node types are here, right? So those are those structures above. And those are just structures of arrays all the way down, pretty much, except for skybox and directional light, right? And then we have configuration. And so I'm revamping the configuration because we don't have the attachment stuff anymore. All that stuff is going away, so we're changing up the configuration as well. And we're going to use all of these different configuration structures, which are more closely tied to how the actual scene file is constructed. And so we have all of these different structures for each of the individual types of nodes, each of those having a base type that is here. So it contains things like the name, the node type, a transform configuration, tags, masks, child count, and then other node configs as children, right? And so this is quite literally just a tree as far as our configuration goes, but that's not how we're going to store things in our actual scene. So we translate from this tree to our flat arrays of stuff, right? So we have that. And then all of these other configuration objects here, I don't need to go over those individually. They basically just reflect the properties that are in our configuration, right? So we have that. Let's see. And then here is where the k-scene configuration comes from. So again, it's just a tree of nodes, right? And specifically, it's a tree of pointers to nodes. And the reason that we went with pointers to nodes is because all of these node configs are actually different sizes, right? So we want to have an array of pointers and then actually allocate the memory that we need for the full underlying type. And then we can use the base type here to cast to the correct configuration type when we need it, right? So I know that's a lot of dynamic allocation, right? But it's okay because it's just config. It's something that we do once when we parse the configuration file, and then we throw it away after that. We're done with it, right? So in that case, I'm totally fine with that, and even the memory fragmentation that comes along with that is fine because it's not in our tight update loop, right? It's a one-time thing that happens when we load the scene. That's hardly going to be our performance bottleneck, right? Okay. Let's see. Are you ever going to need to serialize the tree? Pointers might throw a wrench into that. So I am going to serialize the tree, but the way that our... I'm going to serialize it somewhat similar to the way that the old format was serialized anyways. So I'm not going to write it directly in terms of like writing it, like blitting it to a file. I'm not going to be doing that. What I'm going to do is essentially iterate it and pick out the properties and write them to a KSIN file. And then if we ever, whenever we get to the point of having a binary format, we're going to actually handle that completely different, right? And both the binary format and the KSIN format are going to generate and read in this configuration format, right? So I'm not really too worried about that at the moment. The other way that I could have approached this is I could have had arrays of all of this and then scaffolded a hierarchy that just had numbers in it that were indices into those arrays, right? And that would be a little bit easier to serialize. But I didn't see the need to go that route, at least not for now. Worst case scenario, I just make that translation inside the serializer for the binary format. But yeah. Senior engineer sounds. Yeah, probably. I mean, senior engineer sounds are definitely like grizzled ancient, bones cracking and stuff for sure. Thinking more from the perspective of loading a snapshot to do repetitive testing. I mean, I guess you have a point there, right? I wonder how useful that's going to be in this situation, though. I don't know. We'll play around with it and try it, right? If I do need that, because one thing that we do is, and one thing that I've already started thinking about actually, is when we actually start creating an editor versus, just kind of flying around in the scene. We are going to essentially need two different copies of the scene, as it were. So there'll be like a static read-only copy of it, right? That is basically just the source, and then we make a copy of that to actually execute the scene and like play it, right? And so when I say read-only, I put that in air quotes because it's be written to by the editor, obviously. But every time we go to load a scene that is also loaded by the editor, we don't want to just use that same scene because you have stuff that's animating and changing state and all that stuff. You'd want to create a copy of that and use that. When you put up a double peace sign, you got a bunch of balloons. I wonder if that's the Mac that does that. I don't know. It's not doing it now, though. Unless it's a Twitch thing, I'm not sure. I wonder if it's the Mac doing it. You said it was just like this. I don't know. I'm not sure. I've missed it. I know you guys have mentioned it a couple of times, that I've never actually been looking over there when it actually happens. Yeah, when I did that. Okay. Maybe I have to wait like a couple of minutes and then do it again. Okay. So let's talk about queries for a second. I think this will actually make a little bit more sense if we actually take a look at the API. So I'm going to skip this for now and come back to it. Before we talk about queries, I want to talk about the overall API for scenes in general, right? So we have two modes of creation. We can either create it from a resource, which is essentially a scene file, right? And so that would already be an already loaded scene, right? Scene file, rather, scene resource. That would get translated within this to a scene config and then call create from config, right? Which takes in that configuration tree that we were just looking at. And so, if you wanted to create it in code, you could do it, in your application. You could certainly create a scene config in code there, and then call this, and you'll get the same result as if you'd loaded it from a resource, right? So that's that. Then we have destroy, and then we have update, right? So there is no like explicit load. There is no explicit initialize. None of that stuff. That is all gone by the wayside. We're simplifying this greatly. Now, the other thing is we have the ability to add nodes, right? And these are all by specific type, right? So we don't have a non-typed node. The only closest thing to a non-typed node we would have would be group, right? Which is just a node that you would just use for grouping other nodes. It doesn't really have any logic of its own or anything like that. And so we have add functions for all these different types, and they add to those different lists under the hood. They each also have their own config, as we saw up further up in the file. So the way that this works is you would essentially pass the scene, obviously, a parent node, And if there is no parent node, then you essentially pass invalid handles within this. And then you would pass through a constant pointer to the config. That's just so that we don't have a massive copy going across, right? And then it would spit out a KC node here as the output. So the pattern is exactly the same for all of these. Just the only thing that varies is the structure for the configuration. That's it. And so that's how we add an emitter, add a specific node type. If we go to remove a child, all we have to do is say we pass the scene, the parent node that we're removing from, which could be null if it's a root node, or pass the handle to a child node, which that's actually wrong. That should be a k-scene node, right? Destroy does exactly what it sounds like. It just destroys the node, right? And so this will also remove it from its parent if it has one. It'll also recursively unload and destroy its children. So if we were to call this on a root node, it would basically just recurse all the way down. And then we have a few set functions, as I'll call them. And so we can set the name, we can set a parent. This set parent would essentially, if there's already a parent, it would unparent it from that one and move it to the new parent node here. And then we have position set, which directly sets the position in the transform. We can translate, which basically adds to the transform's position, and then we also have a multiple of that, right? So if we need to move a bunch of nodes at once, or we need to set the position of a bunch of nodes at once, we can pass a list of nodes and a node count and perform that all at once. And because of the data-oriented nature of how we have our transform set up, that'll be a very quick operation. And so we also have rotation set and rotate, scale set and scale, right? Those kind of work the same way. We don't have a quick way to apply necessarily all of these things because that's not quite as straightforward as just doing translation in a group, right? So I've got to think about that. And I've also got to think about if we actually even need to do that, right? Because if we rotate a group of them, for example, generally speaking, you're probably going to be rotating a bunch of objects around a central point in space, probably the average point of all of your selections, right? And so we'd need a little bit more information in order to accomplish that, right? So scaling a bunch of them makes sense. I guess setting the scale to a bunch of them makes sense. I just haven't defined them yet. Let's see. If you ever do want to do it, it just boils down to replacing pointers with indices and backing it with arrays, so it should not be hard to port. Exactly, yeah. At least we have global emotes. Yeah, so I had some technical difficulties before the stream. I didn't wind up getting to it. But I might do it towards the end of the stream. We'll see. We'll see where we wind up. All right. Let's see. The color, I thought you were American. Yeah, that's a habit that I picked up when I was working on overseas code bases for a number of years. I picked up British spellings of things, so it just is what it is. The whole rest of the world spells it that way anyways. I don't know how to pronounce that, so I'm just going to say Sai. Hello, over there on the YouTube side. Welcome. They're all wrong. I don't know what to tell you. Yeah, I don't know though. If you're in a room full of people and they all do something one way, and you're the guy standing there going, "Nope, you're all wrong." I don't know. Chances are that might not be true. All right, so we also have our our typical set position and rotation, translate, rotate, position, rotation, scale, set. The typical stuff you would have. What is going to be a larger topic of conversation is the query interface. So I basically want to treat this a little bit almost kind of like a database, right? In terms of how we actually get nodes, or how we actually select nodes out of this. So we have a generic query here, which essentially queries just the top level node information, right? And we can use this to actually select into specific types of nodes, but we essentially, this right here is the backbone of our entire querying system within the scene. And so it takes the scene as an argument, obviously. It takes a constant pointer to a query, which contains all sorts of flags and other selection criteria that you can set. And then it contains a pointer to a U16, which is going to be the out count of number of things that you selected, and then a pointer to an array of k-scene nodes. And so that will be dynamically allocated within the query, and the user will wind up having to obviously clean that up, which is why we give you all of that information. I could, I suppose, encapsulate this in like a structure, but I didn't really see the point, right? I think just passing a count and in a pointer to an array of nodes is good enough. And so the way that this is going to work is essentially you can pre-allocate an array and send it in here. Because in the query data, you can actually specify what's the max number of results that you want, right? So you can either choose to pre-allocate and send something, a pointer to an array in here, or you can let this function do it to you and just pass nothing there, essentially, or pass an empty array. So there's kind of either way of doing that. The other thing that I do want to think about a little bit, and we're probably not going to get to this tonight, but is k-scene node from path. So to kind of go over what we're talking about here, I'm going to open up zone 2, right? And this is kind of what our current configuration for a level looks like, right? So when we're talking about getting a node from a path, what we're talking about is using the names of nodes to iterate them and their children, and then essentially be able to select a node that way. So for example, if we wanted to do environment the sun, right, we could do that. This does introduce another change that I haven't mentioned yet, though. We used to have the requirement that all names be unique within a scene. That is no longer the case. So if you wanted to, you could do, let's say you wanted to have like a player 2 in here, right? You could have, this be named separately, but player model and player hit sphere for these two could be the same name, right? So this and this could be the same name, this and this could be the same name. And so when you select something from path, you would essentially say player, either dot or slash or something, and then player model, right? And that would be the one that you would actually get. If you do a query and you select by name, you would actually get both of these returned back because they both fit that criteria, right? So that's just something to bear in mind as we continue. Thank you for the follow. I appreciate that. Welcome. So we have all that. I did go ahead and add a point light in here too for us to be able to test with as well. I suppose I ought to actually point out the differences in our config. So the sun now has an X form, right? And I just kind of ripped this direction out of here and put it in there as our quaternion, right? And then, I mean, I did some math to kind of convert this to a quaternion, right? So that's not just like made up numbers, but I believe I got that right. We'll see when we go to test it. And so this direction property is no longer going to be used for this. We're going to use an X form for this guy instead. So the sky does not have an X form defined, which means it'll just use identity. And then down here at the bottom, we do have an X form here defined as well that replaces the old position property for our point light. And so our X form contains the position right there. And then, we have just a rotation, which doesn't really matter for a point light, and then scale, which is ignored. And so that is what that looks like. So that's that. That is querying a node from a path, right? So that is basically my idea there, is that you would just pass a string that has the whole path in it. We would tokenize that string, and then use that to sort of work our way through the hierarchy and actually select the node that we're after. Dr. Elliott, good to see you. How's it going? All right. So we have a couple of other queries in here as well. So we have the local position, transform, blah, 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 getters, right? We have the same for world. So we can get all of those. Those basically just require a node handle, right? So that, and also the transform itself to get it as a mat4, same idea. Now, the rest of the queries are type specific, right? So if we wanted to get a bounding sphere, for example, we could query it directly if we have the node. We could just query the out position and the out radius, or the position and radius, right? It just takes pointers to those things, and that's fine. If we wanted to query a bunch of spheres, if we wanted to get more than one, then we could actually pass a query. And then that would give us a count, and then the positions and the radii, of all of those. Same thing with bounding boxes, right? So we have bounding spheres and bounding boxes. Obviously, we don't have those things in place yet, but they work the same way, and you'll see this pattern with a lot of other things. So static mesh. We essentially just need a way to get render data, right? That's the most important thing that we need to be able to get from static meshes. So we can do this at a mesh at a time, but that's not really the way this is designed to work. Whoops, keep hitting the end key. So the way that this is designed to work is obviously to get a bunch of them. And so we can actually set up a query here where we can include mask information and what kind of culling we want and all kinds of stuff. And I'll show you the query data here in a second. And we can use that to get static mesh render data. And the static mesh render data, similar to a lot of other render datas, contains only the data that we need to actually perform a render of that static mesh. So in this case, it's a static mesh instance ID, a submesh count, and then render data for all of the submeshes, and then an optional tint if we wanted to use that. Skybox render data is pretty straightforward as well. All that has in it is a model matrix, group ID, draw ID, and a pointer to a cube map texture. The directional light render data is also pretty straightforward, right? So at this point, it would be a color, which actually should be a color 4. And then a direction, right? So we take that quaternion rotation out of the transform and we generate a direction on it, right? And then shadow distance, shadow fade, shadow split, multiplier, and padding. So this particular structure right here is designed to be fed directly to the shader, right? So it's already padded out to what it needs to be, and it's ready to go. Same with point light render data, right? This is also designed to go directly to a shader. So this needs to be color 4. Right. And then water plane render data is kind of a similar deal to static meshes, right? So we have our vertex data, our index data, a model matrix, and a material instance that gets passed on, right? So that's that. And then obviously we have something in here to get the hit sphere radius from a particular hit sphere node. And then we have a to-do here to add more queries as we need them. So these are just the ones that I could think of that'd be super important for us to have to be able to set up rendering and whatnot. And so the idea is that you would query the scene from what right now is our render graph, right? With different requirements, and we could set up this query structure with a bunch of different things to actually give us what we need. So that brings me to the query structure itself. So this is a fairly detailed structure, right? And we can always add to this, but it has a series of bits of data that we can use or not use to indicate how we should actually be pulling data, right? So the first thing that we have here is cull flags. So cull flags basically indicates how we want to cull results from, or several ways to cull results from our result set. This isn't all the ways, but it's some of them, right? So obviously, if we put none in here, right, we just kind of move on to the next set of results that I'll show you here in a second. We have frustum culling, we have distance from line, we have occlusion volumes, and we have occlusion volume inverse. So occlusion volumes basically says anything that's inside of an occlusion volume doesn't get included in the list. The inverse of that says anything that is inside of a particular volume gets included and anything outside of it doesn't, right? So we would have to provide an occlusion volume for that, which we don't have yet, but those are essentially, this would be, you could have multiple occlusion volumes within your scene, and this would essentially exclude everything that is inside of all of those, versus this one, which would include a very specific one that you would have to include in your selection set data. So we have that. We can also query inside of a radius or outside of a radius, right? So we can provide a radius and say, I want everything inside this radius, or I want everything outside this radius. And that radius, of course, would also have a point, which I actually don't know. I don't think I added that. That needs to be vec3. I guess instead of radius, it should probably be inside distance. Or inside sphere. Yeah, inside sphere. That's actually better. Right. So supplied radius and position. Okay. So this should be position, right? And I haven't written the queries for all of this stuff yet, so that's why we have that. All right, so that's inside or outside the sphere. So that's another way that we can call. And then we also have tags, right? So we've got 4 different ways that we can use tags and 4 different ways that we can use masks. And so for all of these, the 4 options are the same. So it's either include any, which means that any of the tags that we supply a list of tags. If that a particular node has any of the tags in that list, then we include it. Include all basically says we have a list of tags. We only want to get all of the nodes that include all of the tags that we supplied, right? And then we have exclude any, which means if the node has any of these tags, don't include it. And then we have exclude all, which basically means if a node has all of these tags, then exclude it, right? So that is those, and then we also have the same thing for masks, right? So the logic there will be largely the same, although These are bit masks versus an array of tags, so that'll vary a little bit, but the concept's the same. And then finally, we have one more here, which is a name type exclude bit. Or that, I guess it should just be name exclude bit. And so this basically says exclude nodes with the supplied names. So if this is set, the list of names that we can provide here, right here, is an exclusion list. If this is not set, then it's an inclusion list, right? So we can say, here's a list of names, and by default, this would not be set, right? So we'd say, give me all of the nodes that are named this, or this, or this, right? And we would return that that list back, right? This turns that into an exclusion set, essentially. So that is our call flags, right? Or I guess I should probably rename that, right? It should be, this should be query, just query flags, actually. And let's actually just call this flags. Okay. So for frustum calling, if the frustum calling bit is set, then it would use the frustum. Pretty straightforward stuff. If the direction, if the call type is distance from line, we would need to provide a line, and then this would be used. We already talked about radius and position. Node types, so everything from here down, well, some of these things work with these tags and some of them don't. So node types here, this is an inclusion list unless we turn it into an exclusion list, right? So we have a type here, and this is where I was saying that we would use bit flags, right? So we would just basically have, we would OR together all of the types that we want to query and supply them in a node types, a bitwise integer to be able to do selection on that. And then depending on, how we wanted to handle that for types, we could do that. So types and masks pretty much act the same way in terms of logic. Names is just a list of k-names, right? So k-names also interact with these flags. Let's see, where is it? Name right here. This one, or the not set, which is basically just include. And then, of course, tags is kind of a similar thing to names, right? So either it's going to include any or all, or exclude any or exclude all. And if we don't have any of those flags set, then it defaults to include any, essentially. And then the last thing that we could set here is the max number of results. So if we are in a situation where we say, well, I want to get up to 10 lights that are within a particular radius of us, right? We could then say, okay, set max results to 10. If we find 10, great. That's where we stop looking. If we find less than 10, then obviously we'll be fine. If you set this to 0, that means there is no limit. So generally speaking, the way that this would work is like if you set max results, you probably are also going to set up an array and pass that array in, but you don't have to, right? So the query system will be smart enough to take a look at what you've passed and say, hey, do we need to set up a new array for this or not? And that's kind of what we're looking at in terms of querying. Why do all of your functions return B8? Is that how you do error handling? Yes. So if any of these return false, that means that the operation failed for some reason. Either you didn't provide a scene, or there's something wrong with the node that you passed, or you didn't provide an out parameter, or something like that. Yeah, so that's, you can basically just quickly look at the Boolean to see whether or not the operation was successful. And I haven't added comments to all this because it's not solidified, but when we do, it'll make that much more obvious. Tim and Dua, how's it going? Good to see you. Welcome. All right. So before before the stream started, I was actually working on the query and working out how we kind of want to handle that. I've got a little bit of logic in here in terms of the query itself. This looks like a lot of logic. It's actually not that crazy. So the way that this works is we have sort of an order of operations that we follow. And I'll probably wind up detailing this in the documentation comment for this. But essentially, we start with a selection set, and then for every one of these things that we have, we narrow that selection set. So generally speaking, we want to narrow by the easiest things to calculate first. So that would be things like types, right? And then names, and then tags. Masks is probably also in there. So actually, masks should come right after types, I think. Then by masks, if present. Right. So we do types, then masks, then names, then tags. And then finally, we get to the culling, right? So the advantage to doing it this way is we're not going to be doing occlusion culling on a whole bunch of stuff if it doesn't meet the other criteria that we define simply first. So a good example of this would be if I'm only pulling lights, right? Then I don't need to be scanning a whole bunch of static meshes to see if they are, occluded by an occlusion volume, or if they're cut out by frustum culling or something like that. So we kind of work from the simplest thing to calculate down to the most complicated thing to calculate, in hopes of saving the most calculation intensive stuff for last. So essentially what we do is we start by narrowing the selection by included types. So we have this running property called selected length. So this is basically the number of entries in our current selection set. And that narrows down the list of things as we go. Essentially what we keep track of is we keep track of a list of node IDs, because that's really the only thing we need to track until much later in the query, right? So we essentially just query, or we kind of narrow down this selection set as we go. Let's see. I like that structure. Wish every language had pointers. Yeah, that'd be useful, right? I think the query thing is actually going to work out pretty nicely, right? Because it's open, it's relatively generic, and it's pretty powerful at the same time, right? And I don't think we're going to wind up having to write a lot of logic for it. And in fact, I'm kind of banging out all this logic here, but I think I'm going to be able to split some of this up into reusable functions, instead of having to sort of have repetitious code. So we'll sort that out, but yeah, that's kind of where we're at. Maverick, good to see you. Let's see. Holy smokes, I haven't checked on your progress in a little while. Super stoked to see you're finally at a point where you're building a game. Yeah, awesome. Well, welcome. It has been a bit. I recognize your name. It's just been a bit since I've seen it, but welcome. We're doing a little bit of scene refactoring at the moment. We have started the game, but I kind of decided this was something I really didn't want to put off. And so we're kind of refactoring our scenes a little bit to make them a lot easier to use and more performant. And ultimately a little bit more flexible in some ways and a little bit more rigid in other ways, just to kind of start battening down the hatches, as it were. Kodal, first time chatter over there on the Twitch side. Hello, welcome. Okay, so the way that we do this is, for now, I'm just kind of brute forcing it, right? Just to kind of get it working, and then we can kind of tweak this later to get it to be a little bit more efficient, right? So I'm just kind of brute forcing basic logic here until we actually get stuff, proven working, and then if it proves to be a bottleneck, then we can come back. Ultimately, querying is not something that you want to do super heavily, right? It should be limited to, just a few times a frame, especially these generic queries, right? The type specific queries are going to be much lighter than this, but you know, uh, yeah. All right. Anyway, so we have a selection set of node IDs, right? So the first thing we do is screen by type. So we default our selected length to 0. We create a internal temporary D array. And then we go ahead and we check to say, hey, the node type's mask, is that none, right? So if it's not none, which means that we are actually filtering on node types, then we go ahead and we go through the entire list of types. And first off, we check to make sure that the generation of that particular node is not invalid ID U16. So this means that there's no actual node there, that it's an invalid node or an empty slot, right? So we want to eliminate those. And we only have to do that on the first query. In fact, we should probably have a separate step that does that now that I'm thinking about it, because if this... no, we actually do it here too. Okay. All right, so if we do actually have node types, then we just go through and we say, hey, if the node is valid and the type is included here, then we go ahead and we pushed to the temp array, right? Otherwise, if we do not have any types, we're just saying we're going to select all types. We still need to filter to make sure that we only include valid entries, right? So those are ones where the generation is not invalid ID U16. So we still go through, we still use that temporary D array, and we still push to that, right? So we've got that, and then we go ahead and we update the selected length to be the length of the temporary D array. If we have a selection set at this point, we go ahead and we take a copy of the memory that is in that temporary D array, and we save that off to node IDs by type, right? So we basically copy out of this into this, and then we nuke that, right? And so that is our first selection set, which even if we aren't filtering by type, we've filtered out invalid nodes at this point, right? So it's still done something. All right, at this point, if we have no results, then we're not going to have anything else to filter on, right? If we've filtered out at this point and we've specified some sort of type, or we had nothing but invalid IDs, meaning we had nothing but empty nodes, then there's nothing to proceed with, and therefore we should just go ahead and say, you know what, free this array, which actually we should probably do if node IDs by type, because I don't think that's even going to exist. So let's just guard that. And then we'll say out count is 0, but we are going to return true. Because this is not an error scenario, this just means, hey, the query ran successfully, we just didn't find anything. So we still want to return true to indicate there's been no error, right? And there's no sense in moving on in this case. So we have that, which is actually the types, and actually I believe didn't we also say we should probably also have this based on types, now that I think about it, right? So we have for tags, and we have for masks, right, the ability to say include any, include all, exclude any, exclude all. I'm kind of thinking we should have that for types too, now that I'm thinking about it. Right, and then again, if we don't have one that's specified, we could just default to any, include any, right? So let's actually just do we'll just grab these. And I'm just going to do, instead of type, I'm just going to do query type. I don't want to say query type, right? It should just be query type include any. Or maybe we should say type. Right? Because the query type is querying by type. Maybe I say node type. Query type, node type, include any bit. Yeah, I guess that makes sense. It's a little verbose, but all right. Includes nodes containing at least one of the supplied types. Right. So we'll just change these to types, and then cannot be included with, and this is going to be node type include or node type exclude. So for s node type exclude. So one thing that we are going to have to check is to make sure that we are not including both. We should basically only ever be including one of these, right? So I guess actually, technically, cannot be combined with any other node type queries. Technically. Right? Any other. Technically, that's the way it should work, right? And we should probably check that for each of these types, right? We'll have to verify that. Let me visually split these up for a second. I just realized I didn't use 6. So let's take this guy, put him up here at number 6. Right? And then this one will have to be 14, 15, 15, 16, and 17. Okay. I think that makes sense. Okay. So we should probably modify, I guess, the query a little bit, right? To sort of take those different types into account. And once we have that logic written for types, we can also do it for masks because it works the same way. So I was already kind of partially part of the way there on tags anyways, but oh, this should be masks actually. I've mixed this up. Yeah, this is masks. Okay. So I guess I could finish this off for masks and then take this same logic and put it up there for types. Which actually, I think I said it was going to be types first, then masks, right? So this is types. Then we have masks. Okay. Dingus Dev, thank you for the lurk. Appreciate that. Type squared, right? I could call it type squared, but then people would be like, what the heck does that mean? I get what you're saying, though. Been a busier... oh, man, Maverick, I'm sorry to hear that, man. That's rough. I hope I hope your mom winds up doing much better and recovers. Hope she winds up doing, you know, getting past that and gets back to good health. Let's see. How big is the scope of this game? If you don't mind summing it up really quickly without taking too much time away. So the scope is massive, but not unobtainium. So let me actually open up. Let me open up another window here. I don't actually have this pulled up, so just let me pull up the document for it. And then flashbang. Okay. Okay. Just waiting on something to load, and it'll make sense here in a minute. Okay. So the game is called Shadows of Illumina. It is a 3D isometric action RPG. So the idea is that it's open world, but zoned. So it's split into different zones. We'll see what that's about here in a minute. And it's not going to be too linear of a storyline, right? Or exploration, right? So it's not going to have areas that you can't go if you are, only have a rusty dagger or something like that, right? And so there will be multiple endings based on actions and choices made. We have a whole bunch of stuff here, and I'm going to scroll very fast because this document is 29 pages long so far. So we have a bunch of stuff here for world setting, where we have all the different races. We have the different cities, zones, things, lore, some basic lore detailed out. We've got some combat mechanics in terms of stats, resources, how you progress. So the game does not use the things that a lot of RPGs use, which would be EXP and in levels. We don't have either of those things. If you want to go through the whole game with a rusty dagger, you can do that if you're skilled enough. So we have melee combat, magic, ranged, that kind of stuff, equipable items. Here's a bunch of that stuff. Different classes of things that you can equip, armor, different types of spells, which is going to be a relatively limited number of spells, right? We want to have some different aspected spells, but we don't want to go crazy with it. Control schemes, engine features needed. And then I was, talking about some art style stuff, and I just have some inspiration screenshots here from like some different art styles that I'm kind of thinking of, borrowing some bits from, and kind of combining these. Just a bunch of different styles of stuff, right? And this is obviously what it's going to wind up looking like in programmer art, at least initially. That's why I put that one there. So as far as the world itself goes, yeah, you weren't kidding when they said it was big. Yeah, just wait. So here's the world map, right? Which is not done. So essentially, what we're looking at here is we have 3 continents so far. We have the continents of Thaldor, Dravenholm, and Valora. And so really, really quickly. The background of the lore is essentially the human capital city used to be in something called Dawnvale, and essentially there were 2 religious factions that were there that were always kind of bickering back and forth between each other, trying to one up one another, and it ultimately wound up causing a civil war. And in the middle of that civil war, there was a rumor that was spread that the trolls from Zulthar over here had gone up there and essentially used that as an opportunity to kill off more humans. Um, and so essentially the war that happened here wound up completely ruining the zone, the city, destroying the city, and so the city of Dawnvale became the ruins of Duskvale. Um, and essentially, there's this land is just completely poisoned with darkness and corruption. And the people in Umbrathar, which were a small port town outside of that, are basically standing there. They're the last stand on this tiny continent, trying to keep that from spreading. The natural mountain range sort of prevents it otherwise, but they're trying to keep it contained within here and even trying to restore it. So the story goes that essentially the humans that survived this sailed from Umbrathar over to Briskfjord, and basically traveled down through to the what used to be called Zulthar. So this used to be a troll city here. And essentially, the humans were pissed off that the trolls had supposedly come in there and killed off a bunch of their people while they were already fighting amongst themselves. So they eventually said, you know what, we're not going to fight amongst us humans anymore, but we are going to go after the trolls for what they did to us. So they leveled the city, built their own city called Zuldane on top of the old troll ruins, which obviously put them at war with Zulthar. Zulthar, however, never saw this coming because they had a government official essentially that was in there, who was the one that spread the rumor that the trolls had attacked and taken the opportunity in the middle of this war to kill as many humans as possible, right? And so there was one guy in here that basically spread that rumor to get the humans to attack, to destabilize the government so he could overthrow it and take power. But it completely backfired. They wound up losing one of their cities, and now these two guys are at war. So there's basically a perimeter here, and this is basically hostile territory when you start, right? And so there's a lot more to it than that, but that's kind of where you start the game. So there's the trolls that live here. There's a couple of different types of dwarves, a few different types of humans. I'm thinking about throwing some elves in there at some point, but we have all of these different. Zones, right? So you can kind of see where the zones are all split off. And we have all these different zones. And this continent is more finished than the other one. And we have these capital cities, and there's lore behind all of these guys as well. So obviously this needs a lot more work over here, but yeah, that's basically that's the short version. Let's see, let me just catch up really quickly. Okay, Maverick, I'm glad to hear she's recovering at least. That's a pretty serious thing, but I am glad to hear she's recovering. That's good. I'm glad to hear that. So hopefully that continues. Shouldn't have stepped in. Now I know about this awesome story and have to wait to explore the world. Yeah, it's going to be a while too because I'm the only one working on it. Gonna need supplemental novels. I could write books, I suppose, right? Let's see. Is someone building a C game engine? Have you tried any C frameworks like Raylib or SDL, or did you just use the raw graphics API for Vulkan? I use the raw graphics API. Yep. And in fact, the everything that we've done here, with the exception of a few import libraries for assets, is all written from scratch. So all of our platform code, our windowing code, all of that stuff interacts with the OS directly. We didn't use any libraries for any of that stuff. So I hope that helps. I did not cell phone. You'll have to tell me about that. I did not see that. I had a feeling, Soulfoam. And Automod got you. I'm tempted to not let that through. Just because it's so epic. So Soulfoam basically just tried to drop a D's nuts joke on me. And Automod actually interrupted it. That's pretty great. That's very funny. That's a good one. That's right up there with the eye ladies one. Let's see. well. Let's see. How long did you spend planning this? I've had the idea in my head for a couple of years now, and I've actually gotten a lot of stuff. I have a lot more stuff written in a notebook that I don't have translated to, this document yet. So I've had the idea for a while. I didn't have a name for it, which we came up with not too long ago. But yeah, I've had the idea for quite a while. All right. So, e-girls are eye ladies. Yeah, exactly. You know the one I'm talking about. Yep. Okay. So, narrow by selection mask. So I think I'm gonna do masks first because I already kind of started doing this and we didn't have the flags up here yet. So I'm going to do this here and then basically copy this logic and rework that up there. So we essentially have our flags here for include any or all, exclude any or all. If none of these are set, then we default to include any. We should probably also check. And I'm gonna put a to do in this, or I guess I'm trying to think of a way where I could actually check. I guess we could say if how do I check if more than one of them is set? I guess I'd have to just check it manually, right? I'm going to do that for now. We don't need to do that here. Check if more than one of these is set. Oh, actually, I know how I could do that. Because a Boolean in C is technically just a 1 or a 0. We could actually just do if include any plus include all plus exclude any plus exclude all is greater than 1, then we have an error. We actually can't do this, right? So that means the query is bad. So let's say function name invalid query must only use one flag of the mask variety, right? And then we'll just use function there, right? And this is one of the instances where we return false, right? Because that is an error. So that's a failure right there. So this is just a quick way for us to say, hey, do we have more than one of these set, right? Otherwise, I guess instead of doing this, right? Actually, let me extract this out really quickly. Flags total is equal to that. So let me do that and then say if flags total is greater than 1. And then otherwise I can simplify this check down here. So I can say else if flags total equals 0, right? Then we default to include any, right? So this is an invalid case. This is a valid case, but we need to default to something, and then the other case, the else of this, would be basically be we only have one of those set. Wait, Dr. Elliot, what? What happened? I must have missed something. All right. Let's see. I love notebooks of ideas. Two most recent thoughts I wrote down were Popeye spinach, but it's red 40, and Mount Munchmore presidential bird buffet. That's very funny. The latter is essentially a rhythm game about eating buzzwords and you fly over the. That's very funny. Yeah, I do keep notebooks with a lot of different ideas, right? Uh, Sometimes it helps me to physically write things down. Like actually, the first rendition. Do I still have it here? Yeah, the first rendition of the map actually was drawn on paper, right? All right. Okay, so now we have our flag verification, and now we basically just need to go through and handle the selection, right? So we go through. Oh, I have name count here still. This should be. This is going to be how we need to do it for names. I don't think we actually need this. We don't need this loop. That can go away. Which means we don't need that. We need to get rid of the break, right? Okay, so if we are including all, right, which means that we must have them all set, then we need to check the masks currently set on each node against the query masks. And that must match the query masks that are passed in. If these match, then that means all of the flags are set, right? So that means all masks are present. We push that to the temp, and we say found is true. I guess we could do an else here, an else if. So otherwise, if we are doing include any instead, and we just have a match on one of the masks, right? So the difference here being we're not comparing this value against the masks itself to make sure that they're all included. It just says, this is basically just saying, hey, is one of them, at least one of them present? And if it is, then we consider that found. Else, we could probably just do another else if here. So otherwise, oh, caps lock was on. That's why. Okay, so if, let's see, exclude. So if not found. So exclude any. Actually, this should probably be a separate thing, right? So let's actually do, let's do this. We'll say if not found, then technically these would have covered both other cases. Well, no, not necessarily. We need to actually separate out these parts of the query to separate booleans as well. Yeah, if we do that, then we can actually build the second part of this. So let's take this and do B8 matched all is equal to that, right? And then here we say include all and matched all, right? And then matched partial, B8 matched partial is equal to that, right? And then this would actually have to be, let's actually just wrap this one more time and say not equal to 0, right? And here we can say matched partial, right? Okay, so if not found, then we would need to say, let's see, if exclude any and not matched partial, then we want to push. Right? Or I guess we don't have to do this push a whole bunch of times. Let's just do this. Right? Let's actually just do this. Then we'll do found equals true here too. Right? And then we can have an else if exclude any, exclude all, and not matched all, found equals true, right? And at that point, then we can say if found, right? And we can actually probably just, we can combine these into a single check probably. Right, so we could actually just do let's see, check if all masks are present, and then check if at least one mask is present, right? So this could be simplified to either this or that, right? And then I guess we could just put this in an else, right? And then we don't have to do this. And then we could do this or that, right? And then we can say found equals true that way too. And take this whole thing, put it there. And turn this into an else if actually. Right? And I mean, I realized I could jam all that in one line too, but I feel like this is a little bit more readable to split it out like that. There's probably a more clever way I could do it too, but eh. All right. All right, that's actually all we need. I think that's right. I think that's all we need to do. Yes, okay. So now we can just apply this to our type as well. Oh, you know what we didn't do? We have all this stuff being added to our temp, but we didn't actually we didn't do this bit. We didn't update the selection length and destroy the temporary array. So selection length, and then we want node IDs by mask is what we want here. So we want u16 node IDs by mask, right? And then this should be node IDs by mask. So we take a copy of that, destroy the D array, and then what we base this off of is node IDs by type, which we already did up here. Yes, okay. So we're basically, we base this first query off of all of the nodes, right? Either way. And then we base this second query off the results of the first. And then we base the third part of the query off the results of the second, et cetera, et cetera. But what I really need is I need this logic first. Let's see, that should be here. Because if we don't have any node types, then we don't actually need to do this, right? Which actually, oh, you know what? We're going to have an issue here because if we do have no masks, we need to essentially just set up our array node IDs by mask essentially should become node IDs by type. Yeah, I guess that makes sense. Node IDs by mask equals node IDs by type, right? And then at this point, we can actually do k-free C type array, or type C array. Node IDs by type, u16. And we need u16 previous length equals selected length. And then we need previous length here. Right, node IDs by type equals 0. Okay. Free the previous result array. Just move the previous result array over. Okay. Illumina. No, that's, yeah, I mean, it's technically called Shadows of Illumina. But yeah. Sometimes not being clever itself is itself clever. Yes, exactly. Yep. And a lot of times it's actually faster. So I figure, you know, just doing it the dumb way first is better. Now you have to rename your engine to Shadows of Lumina. So, wait, you called your engine Shadows of Illumina? What? I'm confused. Let's see. I have bad ADHD, so writing in notebooks is essential for me. Many of the pages look like Sam Witwicky's dorm room in the Walls of Transformers 2 movie, if you recall it. I do. If I don't write stuff down, often it may as well have never popped into my head. So you and I are on the same page on that one. I'm very much the same way. I forget crap all the time. Drives my wife nuts. So yeah, I'm trying to get better about writing things down, for sure. I can't keep it all up here. Page when I was exploring half-edge data structures specifically looks like interstellar graphs. That's funny. That's funny. I get what you mean though. Your engine was called Lumina when you made it about a year ago. Thought it was funny because it's similar to you. Oh, I see. Okay. Sarcasm is kind of hard to pick up through text. And I don't always pick it up to begin with. So. All right. All right. So we're essentially going to repeat the same thing that we did before. So this, I think, is what we want to use as our criteria, right? So we want to do that. Okay, and then we also need to change our flags up here, right? Because these are the mask ones. So these are type, which I think I just said, what was it, node type? Yeah. Okay. And then node type variety. Okay. So we have that. Here's our selection set for that. So like this is an example of where I'm saying like we could probably turn this into a function, right? And then otherwise here we still need to, oh, you know what? I lost this though. So before we actually do any of these checks, we should probably, Els Dragoon beat me on the raid tonight, I see. How's it going, gents? Welcome, Raiders. Let me give a shout out to Els Dragoon. If you guys aren't following Els Dragoon, they're a team of gigachads working on 6502 assembly for the NES and building a game in that. And it's awesome stuff. And it looks like you ended your raid early because I was going to raid you again if you were still on. Welcome, Raiders. We are currently working on... well, we're actually working on redoing our scenes for our game engine, but we are working on a action RPG, a 3D action RPG. We called it Shadows of Illumina. It's going to be sort of isometric, but like 3D isometric. It's going to be like an open world but zoned type of game that encourages exploration, with multiple endings and all that kind of stuff. And so the idea is that it's going to be more skills-based than stat-based. So although, there are limitations to that. So it's not going to have the typical RPG elements of experience points and leveling. It's going to be, if you want to proceed through the game, naked with a rusty dagger, if you're good enough, you can actually do that and beat the final boss with it even. But generally, the progression will be getting better weapons and armor and items, so that you can actually, fight your way a little bit easier through the game. So we have so far about 29 pages worth of world setting in terms of all of the different humans and trolls and dwarves, all of the zones with a little bit of lore behind them, and then we also have there's actually a lot of lore in here. We have a bunch of mechanics that we've sort of felt out that we want in terms of movement, looting, navigation, NPC AI, inventory, equipable items, item classes, crafting, item enhancements / enchantments, maybe mounts, resources, attributes, stats, progression, different types of equipable weapons, armor, different types of anima spells or magic, right? Range combat, conjure summon spells, a whole bunch of stuff. Even control configurations, that kind of thing. And so I've also even got a few screenshots of like stylistically, inspiration of some different ideas I'm thinking of in terms of style, right? Sort of like a painterly kind of cartoony type of style. And so that's some of that. And then the other thing that I'll just show really quickly is we actually have this map that I've been working on for a little while. This world map that, whoops, wrong button. Didn't mean to paint there. That essentially shows what the world looks like right now. So there's 3 continents. There's Thaldor, there's Dravenholm, and there's Valora. And you can tell that Thaldor and Dravenholm are definitely the ones that are done the most. And so there's a pretty rich lore so far, at least on a high level. Obviously, I'll drill down to the macro details at some point. But we've got a bunch of different zones, each with their own different types of, scenery and whatnot. And have rich histories and things to explore and things to find and things to discover. And so this is kind of the world that we're building, and we're building it. We are building it using this, which is Kohi game engine. So it's a game engine that we built from scratch. It started off as sort of a tutorial series, and it kind of morphed a few formats and trying some different things. Some things worked, some things didn't. We ultimately landed on the live stream format. But the engine itself is built in C and uses Vulkan as its initial rendering backend. Eventually, it will be also using Direct 3D as well as Metal for macOS. That being said, we do support Windows, Linux, and macOS. Currently, we use Molten VK on macOS to support Vulkan there. It is the engine itself is open source and free. It is available on GitHub, although it's very early days. I wouldn't suggest anybody use it now because it's still very much in construction. But it is Apache 2.0 license, which means that you can use it for whatever you want, personal or commercial. All I ask is that you say that you used it. That's literally it. And so, we've got all the source code here. Here's a couple of screenshots of, these are kind of aged at this point, but some of the things that we have in place. We've got a PBR pipeline in place, cascading shadow maps. We have a water plane that's not displayed here. We have the ability to display UTF-8 text using TrueType fonts, bitmap fonts, a basic UI system, a debug console. The list goes on. And so there's more information here about that. I'll go ahead and drop a link as well in chat. And yeah, that's basically kind of where we're at. So we built the engine. We've recently started building the actual game itself. Yeah, I hope that all makes sense. Let's see. We know you have to get out promptly or we'll get vroed. Yeah, exactly. Super cool. So much work. I appreciate the kind words. Thank you. Yeah, it has been a lot of work. I've been at this. It took me about 4 years to build the engine, but that's like less than full-time hour or less than part-time hours even. So yeah, we've been at it for a bit. Let's see. Does the lore for the zone with the pipeline in the southeast of the map allow for a subtle South Park "they took our jobs" reference? No, it doesn't. Actually, so the lore behind that is basically most of the regions and okay, it's actually a little bit deeper than that. So there's the life force of the planet is called anima, essentially. And it's known as different things around the world. So there's 3 main religious groups in the world that all have their own ways of manifesting it and summoning it and using it. And they all believe that their way is superior, but they don't have an understanding of the underlying use of it, right? And then there's a couple of other non-religious uses of it as well within this world. And so they all have different understandings or what they think their understanding is of the way that it works, but the true underlying anima is not understood by anybody. And ultimately, that's what your character is going to wind up finding out. But basically, so they're one of the non-religious uses of it is for technology. And so there's this Hoshizora zone here, specifically Asetsu, which is the name of the capital city in that area, has the latest greatest technology in the world. And a lot of other places reject the technology because they think it's blasphemous, or they think it's bleeding the planet dry, and they're not completely wrong, right? And so what this is these guys are using all of this super advanced technology that is called Lumitech, right? And essentially that is also using Anima. And then we have this Lumitech pipeline here, which is basically a pipeline that goes to Parchvale. And it's called Parchvale because it's basically been sucked dry of its anima from Asetsu, overusing it, right? And the denizens of this area don't know what's going on because, as far as they can see, the coast has been, sort of from a distance it looks fine, right? But once you get beyond that, you see here that it's definitely not fine. And so that's what this pipeline is for there. It's a direct energy pipeline pulling from other parts of the world. And eventually they're going to be building another one to probably up here somewhere to continue that. But that's basically the way that works, right? And so these guys aren't inherently evil, right? They just they're over-consuming, as we humans do to the planet Earth as well. And so that's kind of the idea behind that, right? But yeah, that's basically the. I hope that makes sense. Anyways, where did you come up with the zone names? I just kind of made them up. I just kind of I've got like a dictionary of words and names that I use to come up with zones, and I just kind of combine them together and change the spelling on some of them. Like you'll notice I use the spelling Vael, Vael, instead of Vale. I do that consistently across here because it was one thing that I just kind of did on accident one day because I'm dyslexic, right? And I was just like, oh, that kind of looks cool spelled that way. And so I kind of just stuck with it, and kind of anything that's called Vael, for the most part, is actually spelled that way. So, it's just kind of a whole list of names or parts of names that I had in my head, or some of these full names I came up with, a long time ago, and I just have a bank of them that I pull from. Let's see. Mustafu, how's it going? Welcome. Forced to get pushed, first time chatter as well. Welcome. Seeing game dev makes other form of programming seem easy. I mean, yes and no, right? It depends on what you're doing, for sure. But yeah, it can be challenging sometimes, for sure. Especially when you're getting into race conditions with GPU stuff. But yeah, there's challenges with everything, right? It's just whether you're equipped to handle those challenges with the tools you have. You might be better at something that I know nothing about. There's plenty of that stuff out there. So, all right. I appreciate the follow. Thank you very much. So, I know that we just got raided, but unfortunately, I do have to get up in the morning for work. So I am going to have to raid somebody else. So we're going to continue the raid train that way. But I do really appreciate the raid once again, Els Dragoon. Thank you very much. And I appreciate all of you guys sticking with me here. And yeah, let's see. I think we had some race conditions tonight also, actually. If it sounds like what I think it is, different things going off at times you don't really get to control. Yeah, so like in the case of Vulkan, it's, graphics threads and stuff like that. And dealing with, GPU memory versus host memory and making sure that's all synchronized. And yeah, there's lots of synchronization to be done in terms of that. So that might be, I'm thinking that's what you're probably referencing, although you guys aren't using Vulkan, obviously, but the concept remains the same. All right, so let me find somebody to raid. Maverick over there on the YouTube side, thank you for chatting so much. And like I said, I hope your mom is feeling better. I know that's a rough thing that you're dealing with there. So I hope she feels better and recovers soon. And thank you for being here and chatting with me as well. Ending the stream early. No, it's not early. It's 11 o'clock where I am. So daylight savings time kicked in. So I'm not sure. Do they do that in Brazil, Taman? I don't know if they do or not. We were having to swap banks of RAM on the cartridge a bunch of times per frame, and it was just not keeping up. Oh, yeah. Yeah, that would be an issue. Yeah, I could see how that could add up quick, Elsdragoon, for sure. We had summertime. Okay. I don't know if that's quite the same thing, like where your time shifts an hour backwards or forwards. We just did that Sunday. This last Sunday. So yeah, it's not necessarily that I'm ending earlier, but I might be ending early to some people who didn't have a time shift at the same time. If that makes sense. All right, let me find somebody to raid. Let's see. Is there anybody doing something semi-related? Not seeing too much, actually. There's a lot of non-English streams, which unfortunately I wouldn't be able to understand, but... Well, maybe the Japanese one, right? But you guys probably wouldn't get that one. I keep hoping, like, as I'm scrolling that I'll just, like, see somebody that has an IDE open. Oh, you don't have it anymore. That makes sense then, Taman. Yeah. All right. I guess we'll go with... There's people that are in software and game development that are just playing games as opposed to actually making them. Which I don't quite understand. Maybe they just forgot to change the category. I might have to just pick one randomly. All right, let's go with... Where was he? I saw him in here somewhere. Was he not on anymore? You know what? I'm going to do something different tonight. Let me search up the... Okay, he's leaving. All right, guess I'm not going to do that one. Sorry, guys. Every time I go to raid somebody, they're like leaving. It's happened 3 times now. um. Okay. You know what? I am going to. I'm trying to like not toss you guys over to like web dev or something like that, right? Um. All right, let's check out this stream. Looks like somebody's doing some modeling in Blender and game dev, and it looks like a relatively smaller channel. So let's get over and see what they're doing. So, anyways, before we do that, thank you guys so much for being here and hanging out with me and discussing and whatnot. It's been a lot of fun, and we will catch you guys on the next stream. So I will see you guys later. Have a good one.